Hi. Okay, so this is for question 10, where we are asked to prove the identity of this trigonometry equation. So as we can see, both sides is trigo. So we will have to make use of some manipulation to change this equation into the right-hand side. So let's start with writing the left-hand side down. So we have this. So by common sense, we want to equate the left-hand side of the equation into the same denominator first. So what we'll get is actually sine square theta minus 1 plus cosine theta. On denominator will just be sine theta times 1 minus cosine theta. So if we remember the rule that sine square theta plus cosine square theta is always equals to 1, we can actually bring in a cosine square theta on the top, on the numerator of our fraction on the right hand side now. So actually, you see this sine square theta is actually just 1 minus cosine square theta minus 1 plus cosine theta. That way we can get rid of the 1 in the numerator and we can further simplify this equation. So if I continue to simplify this, so 1 minus 1, so I can actually remove this one already and just get cosine theta minus cosine square theta. And you realize if I actually factorize this, I get cosine theta 1 minus cosine theta sine theta cosine theta. So you realize that actually it's just a simple cosine theta over sine theta, which gives us actually our cotangent theta. And finally, we can just write a proven to show that we have proven that the left hand side is equal to the right hand side. For part 2 of this question, we realized that they asked us to find the equation in part A, and now it's equals to -2, and they give us a domain for theta. And from the part A of this question, let me just write it down first. We realize that it's proven that it's actually just cotangent theta. Cotangent 2 theta in this case. So what we know about cotangent 2 theta is that it's actually just 1 over tangent 2 theta, correct? And if we change the numbers around a bit, we actually just get tangent 2 theta equals to -half. So given that there is a domain involved in this question, we know that we have to find a basic angle first. But right now, we don't know which quadrant this angle belongs in first. But what we can find is the basic angle. So let's do that first. And we will find the basic angle to be 26.565 degrees using a calculator and to 3dp. So as we are not too sure what are the answers we can accept, all we know is that they have a domain of 0 degrees to 180 degrees right now. So going by your ASTC quadrant, ASTC. ASTC. So we know that the answers we can possibly accept because our basic angle here is negative. It's a negative sign, correct? So actually, we want to accept the answers in the quadrants that when tangent is negative. So we all know that in the first and the third quadrant, tangent is positive, correct? But right now we are not focused on that. We want to find the negative regions. Hence, the angles that we are interested in is in this quadrant as well as this quadrant. We don't know if they fall in the domain yet, so just solve for both. So actually we can get that 2 theta is actually equals to 180 degrees minus 26.565 degrees, or 2 theta equals to 360 degrees minus 26.565 degrees. So if we solve for theta, we get that on the first scenario, we get that theta is equal to 76.7 degrees, which is actually in our domain. And for the second, theta is 166.7 degrees. And you realize that both thetas, they fall in the domain that we want to find. So in this case, we actually accept both, even though at first we realized that we might not have accepted the answer in the fourth quadrant. So just take note that in future, always solve for theta before determining whether it's the answer that we want to accept. Okay, thanks.